We're looking at this RLC circuit, and we're really caring about the capacitance here. We're looking at the power averaged, maximum and minimum dissipated. So we should know the equations for that. P average, that could be either the IRMS squared times R, or it could be the ERMS squared over R. Now, these two equations don't contain the capacitance or the inductance, so we need to focus on another one as well. The ERMS equals IRMS times Z. So let's move the Z to this side, and now we'll be able to square this stuff, and we'll add that into this equation here. So we'll get the P average is equal to ERMS squared over Z squared, and there's an R. But the RMS values, ERMS, that's equal to just the E maximum divided by the square root of 2. That's what we're given right here. So we can use this, squaring everything, getting rid of the square root on the bottom, and plugging that into there. So then in the end, we'll just get the P average equals the E max squared R over 2Z squared. Now Z squared is actually going to be equal to R squared plus XL minus XC squared. So this is literally what we can plug in there. So we'll go ahead and do that again. And we'll basically just say that the P average equals E max squared R divided by 2 times R squared plus, and I'll convert this to WL minus 1 over WC squared. Okay. So this is the equation that we want to start analyzing for the rest of these questions. So from here, we're asked to figure out what the maximum power dissipated would be, the P average. How can we make this maximum? Well, at resonance, we know that these things actually go away, so that we'll be left with just the R's on the bottom, right? So let's figure out what the capacitance is, because we're trying to figure out what the capacitance is. And at resonance, we should know that WL equals 1 over WC. So since we know the L and we know the W's, we can actually solve for C from here. So let's go ahead and multiply C on this side, and then we'll divide everything by the WL. So we'll kind of have like C equals W squared L, something like that. So 1 divided by W squared. How do you get W squared? You can have the Hertz, 76.6 times 2 pi. But we need to square this. And then there's going to be the L still on the bottom, so times 61, 3. Okay, great. So we found that in order to get the maximum at resonance here, maximum power dissipated, we just need a capacitance to be 6.9 e to the negative 5 farads. All right. Now for the minimum, let's take a look at this equation here. Because for the minimum, we would want this to be as large as possible. We would want that to be somewhat close to infinity, and you can get a really, really small minimum here. So let's play around with this capacitance right here. What if we set the capacitance equal to infinity, and we got really, really big numbers for the capacitance? Well, if that was the case, then this number would essentially go away. It becomes 0, and so you'd get WL squared on the bottom, R squared plus WL squared. So you get a bigger denominator. You're getting closer to a minimum, but I don't think that's quite what we're looking for. So let's see if we can change this to maybe go into 0. Let's see that. And if this comes closer to 0, then this number will actually become really, really big. And so we get a huge negative here. We'll square that. We're basically going to get infinity on the bottom. So we managed to achieve our goal by getting the capacitance down to 0. That would give us a 0 power average, the minimum power. In fact, that is one of the answers over here for the minimum power average. It's literally 0, because when you plug in 0 capacitance, you get 0 power average. So we'll go ahead and add that for that answer over there. But we also want to figure out what the maximum was, and that was when the capacitance was equal to that. So that's when these things are gone, and we can actually figure out what the maximum power is by using the calculator and getting rid of this factor. So let's see, it would be the E max, it would be 28.4, and then if we got rid of all this, there would be R squared on the bottom, but there's R on top, so there's just the R on the bottom. So it's the square there times 2 times the R is 4.28. And so that is going to be the maximum power, so 94.22 watts. Okay? And now we're going to be looking at these things. So this is the phase angle. Now the phase angle can be calculated with the simple expression. Phase angle is just arctan of XL minus XC divided by R. So if we can figure those out, then we should be good. Well, remember that when we had the P average maximum, we were at resonance. And the resonance meant that these terms cancel out, meaning that this would be 0 on the top. Well, arctan of 0 is actually 0, so that would be the answer to this particular angle here. And if we take the cosine of that angle, we'll get 1. So that's that part. Now for the minimum, we need to remember that our capacitance was 0. So if we look at the 0 capacitance, we would get basically negative infinity here. And okay, so you get negative infinity on the top here. So arctan of negative infinity, that's basically what we're doing. So we can do that in the calculator, put the degrees there just to make things a little bit easier. But we'll say arctan of negative infinity and see what happens. We get basically negative 90 degrees. So that is the answer for that one. Awesome. And for the cosine, let's just plug in cosine of negative 90 is going to be, as far as I know, that should be 0. So yeah, we've got the answers. Woo.